Welcome back, everyone. This video is about the basics of generics, what generics is in the world of F Sharp. Now, we are not discussing classes at the moment, and classes is something which I'll not really cover into too much of details because I personally use classes as little as possible. There are areas in F Sharp which are kind of impossible without classes, for example, computation expressions and so on and so forth. But I stay away from classes and interfaces. I left the OOP world for very strong reasons. So, in this particular video, I'll talk about what is generics and give you a fundamental idea of how to use generics for more sensible, more generalized, more reusable, more usable actually, functions and data types. So I'll begin with a very simple example of two functions. Add 2 and 2 upper. Add 2 adds 2 to any number, and 2 upper gets a string and it does the 2 upper for it. And then I have a third function called apply, which takes a function f and the first parameter for that function. So for example, we can say let add to result equals to apply add to 10, and similarly we can say to upper result apply to upper on alpha. And also just quickly let's print out these two numbers or these two values, I mean. And again, no surprise there. Apply calls add 2 with 10, apply calls to upper with alpha. Now, what you need to pay attention to here is that add 2 is not a generic function. Add 2 is an int to int, to upper is a string to string. While apply, so let me just write down the signature of apply for you so that you get a better idea of what's going on. F is of type A to B, as you can see here. F is of type A to B. A is of type A. And let me call this param so that, and let me call this func so that you can, it becomes visually more sensible. Param is of type A, and this function returns a B. So what we are saying is apply, give it two things, a func and a param. Okay, and I need to add space here. A func, this parameter, should have a signature of A to B so that the param, which is of type A, can be passed to func. And since func returns a value of type B becomes the output type of this function. And this is what, this is an example like this summarizes generics to a large extent. You could have created a function. First of all, this function in isolation doesn't look really meaningful. When you can simply call add to, why do you need this kind of fancy mechanism to call add to? But that will make sense later. Why do you need apply and all sorts of apply category of functions? They are pretty important in functional programming. But I could have created a function like this. Let apply x func param equals to func param. And if I, for fun's sake, if I say param is int, so then this function is not so much generalized as the previous one. Now the signature of this function now is int The param, because I force this function to be taking an integer for the value param, this function must take its first parameter as int, because that's what is happening here. I can make this function even worse by forcing this func to be of type int, which means that even this generalization is gone, and this generalization as an outcome of it is gone. So on the surface, this function and this function may appear same. The fundamental difference is this is a highly specialized function. So you have apply x, which will take a function of type int to int, will take a parameter of type int, and the output of this function apply x will be an integer. While on the other side, this function is completely open-ended. Use it the way you want to use it wherever this makes sense. That's the whole idea of generics. In certain cases, you can end up writing code which may appear generalized to you, but the compiler has issues, and I have discussed, there's another session dedicated for it where we'll talk about inline functions and constraints and whatnot. So you may end up writing code which may look generalized to you, but the compiler may say, oh, I don't understand, I cannot generalize it. But those are not too many of the cases fall into that category. Typically, your job as a programmer is to think and implement and design as much generalized, as much open-ended ideas as possible. That gives you the flexibility to stitch things. That gives you the flexibility to utilize one thing in more than one way. And generics is a very important. Generic plays a very important role in that. So a quick example. So I'll just give you few quick examples to, since I have not covered lists and arrays and sequences, so don't bother if you don't understand the syntax. So L1 equals to, and I'll quickly say L2 equals to so L1, as you can see, is now an int list, and L2 is now a string list. That's because the way this function is open-ended, list data type is open-ended. List data type says, my job is to provide you a list. My job is not to tell you should you have a list of integers or string or float or student type or a list of functions or whatnot. Generics is all about keeping things open-ended, not making them specialized. Now, reality is specialization is needed in order to solve problems. So it requires a thought process and methodology to move from very open-ended and generalized ideas or implementations to very specialized implementations and ideas, and to finally stitch things. But that's a thing, that's an idea you will learn as we see more and more examples. So the similar thing I've tried to explain here, again, a function which is not so generic. And then I have examples of, this is an example of a generic discriminated union, which is, remember earlier we used type int or string, and then we said it's in either I case of int or it's an S case of string. We created such a data type in previous examples, or we rather use such a data type. If you look carefully, these are effectively the same. Either two cases, int or string, two cases. But either in this case is completely open-ended. It says, I don't care what is the data type when I'm in left case as opposed to I case, which says I am in int case. Similarly, right? So either is a branching data type, which is heavily used in functional programming, where you have something in two states and you make it open-ended, you make it generalized, you make it useful for any use case by using generics. Or because I learned generics, the whole idea for me, generics comes from C++. That's where I learned first. The templatization, you are dealing at template level rather than an implementation. So when you open Microsoft Word and you create a new document, Microsoft Word says select the template, man. So PPT comes with all sorts of templates with fancy designs. They don't care about the content you are about to put in those templates. So either it's a template data type, it's not a hard data type. This on the other side is a hard data type. Deal with I case or S case. In I case, give me an int. In S case, give me a string. And when you say let x equals to left of 10 and y equals to right of 10, you are free. This could have been written as I case 10 from here and S case 10. So you don't need data types like these if you are dealing at a general level. If you're dealing at a specific level, of course you need hard specialized data types and specialized functions. So this is an example of how you can design a discriminated union with open-ended types. Here's another example of a student record type. Now, imagine you're working on a school application and you don't know if the roll number should be an integer or should the roll number be a string or should the roll number be excuse me, be some other type. You don't know. So name will of course be there and you keep roll number an open-ended thing with a generic argument. And depending upon how you construct the record, so in this case I am supplying roll number as integer. In this case I am supplying roll number as string. So if you look at Jack is a student of int and Jill is a student of string. You could have had more generic parameters to make it even more generic, but you use generics where you need open-endedness. You don't use generics where you don't need open-endedness. That's something we learn as we make bad programs and bad solutions and whatnot. So it's a slow learning process. It takes quite a lot of time to appreciate how to use generics effectively. You can't write any and everything open-ended. It just doesn't make any sense. So this is the same example. Yeah. So this is another example. Remember we wrote extracting. So this is another function. Give me any two values. I will give you a tuple. So two tuple is purely generic. If you look at the signature, it's A type, second parameter of B type, and you will get a tuple of B type. Okay, A, B, A star B. I don't need to write it like this. And then there's another function, first of tuple, which is exactly what we created in the previous example. And the signature of this is A star, I don't need brackets, star B. And since we're extracting the first value out of it, the A. So if you look at the signature, A, tick A star, tick B, and you get tick A out of it. So why are these functions generic? Because you don't care what type of data you are dealing with. Give me any two values, I'll give you a tuple out of it. Give me any tuple, I'll extract the first value out of it. Give me the apply function that we created. Give me any function, sorry, f, and I'll call it with A. So as long as A can be passed to F, apply is happy. Apply doesn't need any specialization. So generics is heavily used. One problem with generics is it's a slow process for before you can become very comfortable with generics reading signatures of complex functions. So for just to exemplify F sharp sequence module. So if you go here and if you read the signature of such a function, it's so it's confusing, especially functions like these, choose a source which is this, tick t to tick u, and so on and so forth. That's something you will slowly learn, but you have to understand generics at a very fundamental level. It gives you the capability to keep things open-ended, and when you are using a third-party library or built-in F sharp libraries, and when you are dealing with generic data types or generic functions, you are dealing with things which are open-ended. The provider is giving you the capability to use those according to your use cases. So they have not implemented a use case, so the documentation is high level open ended, that if you do this, it's not about a specific case. So dealing with things which are generic in nature, understanding and going through that documentation is a slightly tricky process, but we improve as we use more and more of such libraries and functions and data types. uh, it slowly makes more and more sense. Righto, see you in the next one. Bye bye.